All right, for those of you watching the video here, the first section on our test is going to be one 5-minute timed part where I give you the degrees. You have to give me the radians and the point from the unit circle. Then you also have to sketch the graph of sine and cosine. So I'll show you this. You can pause it and time yourself for 5 minutes. And then a second time, if you want to practice again, is right here. You can pause it and time yourself for 5 minutes. Okay. The answers to the first one are right here, and you can see the graph that I want. Okay, and now we'll look at the answers to the second time here. So, all right, so you trade them. Did you guys trade them yet? Okay. All right, so let's see, where did we leave off? Gianna? Okay. What's our radian measure for 180? Pi. Good. And the point, Joanne?
-1.
All right, -10 is our point. Okay. -10. Okay. Alec, how about a radian measure for 315?
That's blank. See my paper? 7 pi over 8.
7 pi over
4.
4.
Oh,
7 pi over 4.
Is that a 5?
Actually, it says 8.
No, it says
We're
4.
not
Pretty sure it says 8.
five,
It says 4.
All right, so Brett, what's the point then for 315?
2 radical 2 over 2. And negative
Good. Radical 2 over 2, negative radical 2 over 2. That's a 45-degree reference angle, so its denominator is 4. It's in the fourth quadrant, so only the y is negative. All right, Jiho, how about 240 in radians?
4 pi over 6.
4 pi over 3. Okay. That has a 60-degree reference angle, so the denominator is 3. It's 4 pi over 3. And then the point. Edward, what's the point here for 240?
240 is what's wrong here? Negative 1/2, comma negative √3 over 2.
Very good. Third quadrant, both of them are negative. Okay. All right, how about 60 in radians, Jason?
Pi over 3.
Good, pi over 3. And what's the point, Tristan?
1/2, √3 over 2.
Good, 1/2 √3 over 2. And then for 150, Evan?
5 pi over 6.
5 pi over 6. Okay. And then for the point, Amanda?
-√3 over 2 and 1/2.
Negative √3 over 2 and 1/2. Okay, good. And of course the sketch is the same as the first time. You should have your points at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? And if you use your unit circle, those are those easy points.
Okay.
You know, the 1, 0, 0, 1,
You're so close.
0, -1, and back to 1, 0. Okay?
Wait, can you like that? Can you grab it over?
Sure.
It's early.
Okay?
Yeah.
So that's 2 sets of practice. And again, that'll be the first 15 points on the test. It will be a 5-minute timed portion of the test. Okay?
Oh, I see.
So, any final questions about that before we move on?
What is up?
Hmm?
That's my question. What's up?
Okay. Any relevant questions?
Relevant question.
Sorry.
All right.
It's not a relevant question.
Okay, so now let's take a look at our homework questions. Did anyone have a question from the right triangle trig problems?
Is there going to be right triangle trig on the test?
There will be a right triangle trig problem on the
Is it going
test.
to be like a word problem?
It could be, yeah, it's going to be a word problem. Okay. We had this. We had an airplane, a mountain. We had the fire. We had the boats.
I have the planes.
And then we had another airplane one, and then the wave motion.
We're
One.
gonna have to know that for the test.
What's that?
Harmonic motion.
Well, here's the thing with the harmonic motion, this was my point yesterday, is the fact of the matter is harmonic motion is simply, if you remember the formula, which I just showed it to you, but it's A times the sine of, you had that omega times t,
The W.
and omega times t, okay? Where t was your time, omega was, to relate it to what we've been doing, that omega was just your b, and the t was just your x, okay? So essentially you've been doing these. The nice thing about the harmonic motion ones is there's no like time frame that we're really set to, like you're not going to have this set to like a time on the clock. Here we have some random time 0 and we know it goes for 10 seconds. I think it was 10 seconds. So you're automatically going to set your starting point at 0. There's never going to be a horizontal shift on a harmonic motion problem. And also, there's an arbitrary height here. You're just figuring out from the highest point to the lowest point. So this midline is just an arbitrary point. So the way we look at it is that midline is going to be 0. When we go up to the high point, we're in the positives. When we go to the low point, we're in the negatives. Okay? So you're never going to have a vertical shift either. Okay, these harmonic motion ones are nice because you never have any shifting, just amplitude and period change. Okay? So that's essentially all it is there. Here, with the picture they gave us, since the difference between the high point and the low point is 3.5 feet, what would the amplitude be? 1.75, okay? So here, we automatically know A is 1.75, okay? Now, it says that it goes, if you look at this, it goes from its low point to its high point, and it returns to its high point every 10 seconds, okay? And actually, the key thing I want you to notice here is it returns to its high point every 10 seconds, okay? So what is that telling you?
That the period length is 10.
The period length is 10, okay? Now, how does the period relate to our graph, our equation?
2 pi over b.
2 pi over b, all right? So 10 equals 2 pi over b. So what does b equal?
Pi over 5.
Pi over 5. Multiply both sides by b to get it out of the denominator. Divide both sides by 10, and you get pi over 5. So the equation of this is y equals 1.75 sine of
Pi over 5.
pi over 5.
Times t.
Okay? Times x. Okay? Alright? Now, actually, there's one little thing I have wrong here. Can someone find it? Look at the last sentence.
I didn't write it in. So x is 0.
Cosine?
So there's, wait.
Is it cosine?
Why?
Because it starts at its high point at time t.
Exactly. Okay? We're at the high point when time is 0. Okay? And I guess I should be using t's here, shouldn't I? Since they said t. Okay? But since we're at the high point at time 0, that means we're going to use cosine. Okay? Can I actually borrow your Sandy? Just so you have, we've had that. Okay? I just saw that and this is perfect, okay?
It's not gonna work.
The difference is this, well it'll work well enough. When we're using cosine, it's like we're holding it all the way up and then we're dropping it. So it's starting at the top, right? Yeah, thank you very much. But that's okay. You guys get the idea. That's the highest it's going to go, and then it drops, and you can see that oscillating, okay? And it keeps going, okay? The highest it's going to go, though, is where it started, so that's why we're using cosine. When I use sine, it's like we're starting here, and I went, that's the midline, and then I went like that,
Start from bottom now.
okay? So, okay. So sine is when we're starting at the midline and we start by going, pushing it up or whatever. Cosine is when we're starting at the top and it's like a bungee jumper. Okay, we just drop it and it starts oscillating. That's what we have here because we happen to start our time when it was at the peak. Okay?
Ha. You took it from me.
All right. So, any other questions from the problems here? We've done a couple of them in previous classes. I'll
Can we do the mountain one?
show them. Sure, we can do the mountain one. There's our solution for 29. Oh, 29 was kind of cool. We saw one thing. We'll get to the mountain one. There were two parts to this one, or two different ways you could have thought about this. It said our speed was 275 feet per second, and it said find the altitude after a minute. So you could approach this one of two ways. You could have used right triangle trig by first of all multiplying 275 feet per second by 60, and you got 16,500 feet. That's how far they traveled in a minute. Okay? Another idea, and especially if you've had physics, you may have thought this way. But thinking of it as a speed instead, and using right triangle trig over here on the right to find a vertical speed. And then whatever that speed was, you would multiply by 60. That speed would be in feet per second. But that's how fast your altitude is increasing in feet per second. You multiply that by 60, and that'll give it to you. So you would get the same thing whether you did this over here, sine of 18 equals x over 16,500, or if you did this, sine of 18 equals x over 275, and then multiplied it by 60. Okay? So, two different ways. That was kind of neat observation we made earlier. But let's take a look at the mountain, okay? A sign on the roadway at the top of a mountain indicates that for the next 4 miles, the grade is 9.5 degrees. Okay? Find the change in elevation for a car descending the mountain. Now, when you're talking about 4 miles on the driving down the mountain, they're talking about the road. All right, so that is our hypotenuse right here. 4 miles. Okay? So that is our 4 mile distance, which I guess they stopped right here, so I should probably stop it there too. Okay? The grade here is an angle of depression. Or if you're driving up the mountain, it's an angle of elevation. Remember we said it's a difference of perspective, those terms. Alright, so you'll see down here, they made this little angle right here, the 9.5 degrees. Okay? So we've got this right triangle with a 9.5 degree angle. It said find the change in elevation. Which side of the triangle are we trying to find? The red one or the blue one? The red one, okay. Change in elevation, that's vertical. So what trig function would we use to find that then?
Sine.
Sine, okay. We're going to use sine of 9.5 degrees, and that's going to equal,
X over 4.
there you go, x over 4.
Oh,
Okay, and you can multiply by 4. Make sure your calculator's in degrees. But you multiply by 4 and get your answer. Okay, did anyone happen to get that?
.66, I think.
0.66 what?
Just .66.
0.66 miles. Okay? So we go down a little over, or about almost 2/3 of a mile. Okay? Right. Any other questions you guys have? All right. Let's do a couple more practice things here. What does this equal?
Cosine theta.
Cosine of
Theta.
theta. Make sure when you give answers that you put the theta in there, okay? Because really that's the biggest reason why this works, is that this is 90 minus theta and that's theta, okay? How about this?
Cosine.
There we go, secant squared theta, okay? Now, Edward mentioned cosecant squared. What does that equal?
Cotangent.
Plus 1, there we go. Cotangent squared plus 1. Now remember, both of those are derived from the other Pythagorean identity. Which one was that?
Sine squared plus cosine squared
Theta
equals
plus
1.
cosine squared theta equals 1.
Alright, sine squared theta plus cosine squared theta equals 1. And we got both of these by first dividing by sine squared. And that gave us 1 plus cotangent squared equals cosecant squared. Then we divided everything by cosine squared and we got tangent squared plus 1 equals secant squared. Okay. How about this? What if we have? Well, it doesn't like that. Okay. What if we have this? 1 over the secant of theta.
Cosine.
That's cosine. Okay. What if I have cosine over sine?
Cotangent.
Good, cotangent. Alright, so I'm not going to ask you to do proofs this chapter. We're going to do that a lot in the next chapter. Okay, but I am going to ask you some of these identities. Okay? But remember there's 5 of them on there, so. Okay? Alright, give me the amplitude and the period for these functions, okay? Let's say that we have y equals 4 plus 2 sine of 3x minus pi.
Amplitude is 2.
Amplitude is 2. What's our period?
2 pi over 3.
2 pi over b, which in this case is 2 pi over 3.
Yeah, I think you said it
This is b, right?
Yeah.
And the period is always 2 pi divided by whatever b is.
in 3.
Okay. Alright. Let's try another one. Y equals 0.5 cosine of 1/3 x plus pi over 3 minus 1. Okay. What is it?
Pi.
Amplitude is 0.5. What's our period?
6 pi.
Okay, 2 pi divided by 1/3, you flip and multiply, we get 6 pi. Okay? So, alright. Just for some extra practice here, let's see, suppose I have this. I have a max point at 328, and I have a min at 720. Okay, and we're going to use y equals d plus a sine of bx minus c. Okay? If I give you this and I tell you to use a sine curve, that's actually enough to figure out everything. Okay?
Yeah.
What's 24?
Amplitude.
The midline.
No.
The midline.
Midline.
The midline is 24, which is also what in our equation?
0.
D.
D.
Whoever that, was that you?
That was 0.
Alright, so 24 is D. That's our midline. So good, our amplitude is 4.
Wait, what?
Our amplitude is 4 because the distance between the max and the min is 8. So half of that is 4. Okay, so that's our amplitude.
Period is 8.
Period is how much?
8.
8.
Why do you say 8?
Because it's from the max to min is 4. And that's half period. So.
Okay, so half the period. Okay, we go from a max to a min in 4 units, right? Okay, so, you know, here's 3, 4, wait, no, 3,
3, 5, 7.
5, 7. 3, 4, 5, 6. Here would be 7. Okay, so yeah, our period is 8. All right. You can also get the horizontal shift and
B
vertical.
is a quarter pi.
How do you find B?
2 pi over B is
Yep. 2 pi over B equals 8.
How do you get 8?
Because this distance of 4
Come on, Gil.
is half a period.
You gotta get the finish.
From the max to the min is half the period.
Come on, Evan.
So the period would be 8. Okay.
Here, come on, Evan.
And then you can solve that to get B. B would equal 2 pi divided by 8 or pi over 4. Okay. Then you can get your horizontal shift is always C over B. So our horizontal shift, we need to go back another 2 to get to the midline. Okay? If our period is 8, then each quadrant is 2, right? So that's going to be our sine curve. So if that's 8, we have to go back 2 more, so actually that's going to hit 1. Okay?
Why did you do the
So the horizontal shift is 1. So 1 equals C over pi over 4. And so we get C actually equal to 4 over pi. Which is a little goofy one, but we just made it up.
why
So.
720 pointing here?
Oh, I just drew it fast. I wasn't paying attention to the Y's.
Happy holidays.
Oh, thank you very much, Evan. Appreciate it.
Have a good day.
Thank you. You too.
Have a good day.
I'm gonna get it period equal 8.
So we got our period equal to 8 because this is from the max to the min is 4 units.
Yeah.
And if you look at your sine curve, from the max
Oh,
to
four-
the min
4 times
is
2.
half of the pi, half the period, so you have to double it to get your full period.
Alright.
Yeah.
Alright, thank you.
You're welcome.